Hello everyone. We are going to be going through the first section in Unit 5 today, which is sequences. Certain parts of this are a little tricky, but we're going to work through it. We will work on some of the stuff a little later in the unit as well because it comes back up again. So a sequence is a set of numbers in a specific order. So let's get a pen that works here. A sequence is a set of numbers in a specific order. Now each entry in a sequence is called a term. So you have the first term, the second term, the third term, and so on and so forth. The way that this is denoted is a little different than in other math. We're actually going to have an A, and for the first term it'll be called sub 1. A sub 1, the second term is A sub 2, the third term is A sub 3, and so on and so forth. Those are called subscripts. Superscripts are exponents. Subscripts tell us what term we're going to in a sequence or a series. There is still a domain and a range in these. The domain is pretty easy. It's just the term number. So those are easy. It's just the first term, second term, third term, fourth term, etc. The range is the other part. That's the value of the term. So whatever value you get for the first term, the second term, the third term. If you're looking for something you don't know, that's called the nth term. And that is denoted as A sub n, the nth term. So we're going to go ahead and jump forward, and we're going to do a couple examples here. We want to write down the first 6 terms in each of the following sequences. So starting with this one, you need to have a strategy. My strategy goes, well, I need to find 6 terms, so I'm going to write down 1, 2, 3, 4, 5, and 6. So those are the domain elements, and to find what goes with them, you plug it into the formula that's right here. So I'm going to go ahead and plug 1 into that. So I'm going to have 1 minus 1 over 1. Well, that gives me 1 minus 1 is 0 over 1, which is just 0. I'm going to do the same thing for 2. It's going to be 2 minus 1 over 1. Well, 2 minus 1 is 1. Divided by 1 gives me a 1. For the third one, it's 3 minus 1 over 1, which gives me 3 minus 1 is 2. See, look at that. I'm already making mistakes. Come on, Sheehan, get with it. 2 minus 1, and on the bottom up here, that's actually an n. And this is how easy you can mess things up. It's pretty quick. So for the second term, it'll be 2 minus 1 over 2. Well, 2 minus 1 is 1 over 2. For the third term, again, that's an n on the bottom, so it'll be 3 minus 1 over 3. 3 minus 1 is 2 over 3. The fourth term is going to be 4 minus 1 over 4. 4 minus 1 is 3 over 4. And I'm going to go ahead and just write the others in here. You can fill in the boxes as you need to, but I want to go a little quicker. So that'd be 4/5, and that's going to be 5/6. And you could see the pattern developing there pretty quick. 1 over 2, 2 over 3, 3 over 4, 4 over 5, 5 over 6, 6 over 7, 7 over 8, and so on and so forth as far as you need to go. Looking at the next example, this one is a little trickier. There's a little more to it, but we're going to follow the same pattern. So I'm going to write down 1, 2, 3, 4, 5, and 6, and make myself a nice little table here. I'm only going to do the first 3 terms. I'm not going to go through the whole thing. So the first one, our n value is going to be 1. So I'm going to have negative 1 to the 1 minus 1. And then I'm going to have 2 over 1 because my n value is 1. So I had to plug in right here and right here? Well, 1 minus 1 is 0, so that's negative 1 to the 0 power, and 2 over 1 is just 2. So that is going to give me a final value of, well, anything to the 0 power is 1, times 2 is just 2. Going to the second one, I have negative 1 to the 2 minus 1 this time, times 2 over 2. You'll notice again that my 2 went here and down here. Well, 2 minus 1 is going to give me negative 1 to the first power, times 2 divided by 2 is 1. So negative 1 to the first power is negative 1, times 1 gives me just a negative 1. And the third one is going to be negative 1 times 3 minus 1, and then 2 over 3. One more time, my 3 came here and here, because in the original, I had an n there and an n there. So that will give me negative 1 to the second power times 2/3, which is going to be a positive 1 times 2/3, which is just 2 over 3. I'll fill in the next couple boxes there so that you can see if you can get them. You would actually get negative 1/2 here. You would get positive 2/5, and then you would get negative 1/3. And something I would like to point out is that you have a negative here and then a positive, a negative and then a positive, a negative, the next one will be positive, negative, positive. This is actually called an alternating I hit a button that I didn't mean to, sequence. And that alternating sequence comes from this whole piece right here, negative 1 to the n minus 1 power. That's going to make it go positive, negative, positive, negative, positive, negative as you keep going. All right. We want to talk quickly about an explicit definition. And I'm going to skip example 1 there because it's a little tricky. I'm going to go straight to example 2. An explicit definition gives us the formula of a sequence based on the general term a sub n. It allows us to jump to any term in the sequence. So if I want the 100th term, I can jump straight to term 100. I don't have to go all the way up to it. So to do this, what you want to do is look at the numbers they gave you. Well, to go from the first term to the second term, I'm adding 2. And some people would just notice that that's plus 2, plus 2, plus 2. If you look at it a little differently, though, you would notice that then to go from here to here, it's plus 4. And to go from here to here, it's plus 6. And the next one would be plus 8, plus 10, plus 12, and it would keep going like that. So what you want to do is you want to start with your original number, which was 1. So our first term is 1. And we're adding on 2 times, well, this first one here has to be 2 times 1. To get to the second term, it's 2 times 1. To get to the third term, it's 2 times 2. And to get to the fourth term, it's 2 times 3. So that's actually whatever term number you're at, take away 1. And we are going to work on this a little more when we get into arithmetic and geometric sequences, how to get that specific formula. This is just an example of how if I wanted to go from the first term straight to the fourth term, I could plug in a 4 here for my n. So I'd have 1 plus 2 times 4 minus 1. So I'm looking for my fourth term. That would be 1 plus 2 times 3, or 1 plus 6, which gives me 7. And if you look back up here, I have my first term, second term, third term, and my fourth term is 7. If I wanted to jump to the 100th term, I could plug in 100 for n, and it would give me the 100th term so that I wouldn't have to write them out all the way going up. This last one here is a little trickier. You'll notice right away that it goes positive, negative, positive, negative, positive, negative. So it's an alternating sequence. That alternating sequence, the only way you can get that is if you have a negative 1 to the n minus 1 power. So that has to be the first thing in our formula, negative 1 to the n minus 1. That makes it an alternating sequence. Then I would want to rewrite this as 1 over 1. So now I'm going 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. So if you notice, that actually matches up. This is my first term, second term, third term, fourth term, and fifth term. So this is my alternating sequence part. And then the other piece is actually going to be 1 over whatever term I'm on. So if I wanted to jump to the fifth term right away, I would plug in a 5. So I'd have negative 1 times 5 minus 1, and then 1 over 5. Well, 5 minus 1 is 4. Negative 1 to the 4th power times 1/5 would give me a positive 1 over 5. And you'll notice that that's exactly what we have up here. As I said before, there's another way to define things. And that's when you have to go one step at a time. So the first term, the second term, the third term, and so on. This is called being defined recursively. Okay, and the formula is called a recursive formula. So what you have to do here is we want to write down the first 5 terms. So I'm going to follow the same kind of a pattern. I'm going to write down 1, 2, 3, 4, and 5. Now the difference is they tell you that the first term is 1. Right here, S sub 1 is 1. So I know that it's going to be 1 down there. And they tell you every term after that is going to be 4 times the previous term, Sn minus 1. So the second one here is going to be 4 times 1, which is 4. The third term is going to be 4 times 4, which is 16. And then you're going to have 4 times 16, which is 64. And you're going to have 4 times 64, which is 256. So you'll notice that this piece here is going and getting pulled up into the next term, getting pulled up, getting pulled up, getting pulled up. This 256 would go up to the next one if you had to keep going. The next one is even trickier because they say that each successive term is the sum of the 2 before it. So again, I'm going to write down my 1, 2, 3, 4, and 5. They tell me that my first term is 1. They tell me that my second term is 1. And they tell me that every term after that is going to be the one 2 places before it and the one place before it added together. So I'm going to take this and add them together. So this will be 1 plus 1, which is 2. The next one is going to take the 2 before it. So here and here. So it will be 2 plus 1, which is 3. The next one is going to take these 2 and add them together. So that gives me 2 plus 3, which is 5. And then the next one after that would take these 2 and add it together, and you'd get 8 for it, and you'd keep going like that. I know that's a little tricky. That one is probably the toughest one on here because it's kind of confusing to follow. The last thing is if you want to find a recursive definition. So they give us several terms here. The bell rang and it's getting loud out there. I'm sorry about that. So they give us right here, they give us 1, 2, 3, 4, 5 terms. So I'm going to make a table for 1, 2, 3, 4, and 5. So I know that my first term is 4. I know my second term is 8, then 12, then 16, and then 20. So we need to figure out this middle part now. So I'm starting with 4. How do I get from 4 to 8? Well, I can multiply by 2. I can add 4. Okay, so there's a couple ways. We can do times 2. We can do plus 4. Let's go to the next one. How do I get from 8 to 12? Well, you'll notice right away that's another plus 4. Plus 4, plus 4. So each one of these is the term before it with 4 added on. The way you write that is you would say that a sub 1, you have to give them the first term, is 4. And then every term after that is going to be 4 plus a n minus 1, which is the term before it. Again, we're going to talk about explicit and recursive definitions a little more. I just want to get you a little bit of exposure to it. So this would actually be the whole thing that you would have to have. I have to get back to my room because the bell rang. We'll talk about this a little more tomorrow before we get started, but I hope you have a wonderful evening.